Hi guys, hope you're doing good. So we are starting Leetcode hard problem series. Why hard problems is Leetcode. Why hard problems is from Leetcode we need to learn the problem solving skill. That is what is seen in the interviews and coding contests. So here, firstly, we are going to see how to understand the problem, like what to analyze what is given and what is needed, and to solve it in brute force, and again optimize it further to get the actual solution. We are starting with the problem number 4, median of two sorted arrays. So in this, we are given two arrays, nums1 and nums2. Let's think it. Let's take this as an example. So if we take this as an example and let us given size m and n, and we have to return the median. So generally, what we do get a sorted merged array, which is and take the middle elements to it and get the median. So this is how a human brain works. So here we know what is given and what is needed. So the same thing in brute force, or the worst case where we do it is going to each and every element and getting this merged array. So first we check 1 and 2, we get 1, then the pointer moves here, 2 and 3 we get 2, then the pointer moves here, 2 and 3 and 4 we get 3, 4, 5, 6. So but we need the complexity of log m plus n. So getting this is not the deal. This is simple. So this thing needs to be optimized according to this problem. So that is why comes under the hard category. So if we know see the steps involved, merging plus sorting, next finding median. So the time is taken here of m plus n. Since the time is taken here, we need to optimize the step. But merging is a single step, but sorting, the best case we are getting O of n log n. So this is not the way we'll get an easy answer. So we need to find a way where we'll get it without merging and sorting, like without merging at all. So when we have this array, what are we needing here? Do we need the whole array? No, we just need the middle elements. So when we say that we are needing middle elements, we can like think, tell that if we split it in the half, we can have this element and this element come up. Or else if we have one more element, so 7 in this, we can have like this and we can take this element. Finding median would be simple. So you can come up that why are you directly partitioning? Why are you partitioning? So this is my thought process where, or this is the thought process where median is the middle element. So it is coming up from that. We just need the middle part. We don't need everything or the whole array. So when we are thinking as such, The next part is without merging, removing this part, how we are to get this thing. So we what we originally have is this. So from this, we need to go to this. So for that, we need to partition. We can do partition in both. To get this, we can partition it like this. And if we see left is 1, 3, 2, and right is 5, 4, 6. So each is having three elements. Then the this is working. The partition is can be done. So first observation, partition works. And now the main question is working is fine. Where and checking correct. So where can't be told, but checking can be done because what we know from the above array, everything on the left is less than everything on the right. That is what we know. So what we can do is instead of checking every element with every element in this, we can go by taking this one, this, and this. That is the things near the partition because we know that both are sorted arrays. So L1 would be 3, L2 would be 2, R1 would be 5, R2 would be 4. So how can we check that every element in left in is less than every element in right? So we this will be obvious. So we need to check crossly only. So L1 should be less than R2 and L2 should be less than R1. Here it is working. So 3 and 5, sorry, 3 and 4 are 3 is next. 4 comes after 3. So and 5 comes after 2. So this is working. So the partitioning is correct. And then if we can take max of left, then the max of right. So, so no, we can take max of left and min of right because we want the part this part and this part. So from this max would be 3 and mod would be 4. We are getting the same 3 plus 4 by 2 is 3.5. So checking the partition we are getting it. So where is the next part? So if we partition it wrong, where we partition it here, which would give us L1, 1, 3, 4, 6. Just like this is fine, but this is not fine. L2 is greater than R1. So we are having a problem here because L2 is having something, so R2 is having something less. R1 is having something less compared to L2. So we need to move this partition right so that R1 also comes into L2. The right one comes into left. So if this is happening, then partition move right. So we'll need to check that other one also. It is this, it is here, and it should be here. And L1 would be 5, R1 would be max int. Okay, I'll take this one because nothing is there here. And here should be maximum, here should be minimum. L2 would be min int, and R2 would be 2. See here, it is not, this is fine, but L1 is greater than R2. Then partition should move left because L1 is having something. This left side, the first array is having something that needs to be moved right. So partition moves. Hence, we have the conditions. So here we are moving left and right, and this brings up the concept of binary search. So using binary search, you can check L1, L2, R1, R2, and see if these are fine, which is L1 should be less than R2 and L2 should be less than R1. Is this fine? We have answer. Then L1, if it is greater than R2, then move right. L2 is greater than R1, move left. So when we are getting this symbolizing is the binary search. So hence we can tell this and make it up. And when we find this one, then we'll get the answer, which is max of L1, L2 and min of R1, R2, provided m plus n equal to percentile 2 equal to 0. So otherwise, max of L comma L2 would be then m plus n percentile 2 would be 1. Okay. So now let's start the code. First, for the arrays, we'll get the lengths, and for the next, since it's a binary search, we are trying to implement, we'll take every time first one to be the shorter one. Okay. Next step would be to define the low and high values for the search, which should be initially 0, and this would be the maximum value for the first array. So while loop, then we will have the partitions. And for the second one, it would be the whatever we want, the number of elements we want on the left side, which would be 2 minus what already we have from the first array. Okay, then this is, and then we'll get the leftmost and the rightmost elements. So we would be having the edge case where the partition is all full to the left. Then we would be handling it by giving it the min value here. Otherwise, just okay. And the same way for right. It would be max value. That is normal. Okay. In the same way, we can have it for the second array. Okay. And next, we would be checking if the array, sorry, the left and right partitions are right. If the left one is greater, then we need to shift to the right one. So the partition shifts left. So the height would be okay. For the next case, left 2 is greater than right 1. It will be the partition to the left. Okay. So we complete this. And for the normal case, when the both are satisfied, it would be checking for the median, giving the median. If the complete length is odd, then we would go with this. And for the next case, which where it is even, we will return or take max of left 1 and left 2. So we have the right max or right min. Okay. And next would be between the average of both. Yeah, 2.0 because the output is double. Okay, we need the output as such. Then everything's completed, and we'll have a return statement here because just having it. Let me call it missed. And if we submit, that's right. We month. Got it. You'll find this in the description. Make sure to subscribe. Thanks.